Yes, ma'am.
Okay. All right, so we will see how to calculate the reaction forces of 4 different cases. Okay, so I want all of you to start drawing. So the first case, it's going to be a cantilever beam and the load, this is the length. Okay, so you will have a reaction force here because it's a, I'm going to name this as A and B. So at A, you're going to get a reaction force, a vertical reaction force. Okay, and a moment in this direction, MA. Okay, so what will be the value of RAV? So RAV is going to be equal to all the forces in the opposite direction, so which is W. Okay, so we're going to take the sign convention as this: downward force as positive, upward force as negative. Okay, and we're going to consider anti-clockwise as positive and clockwise as negative. So that's the convention we're going to use throughout this unit. Okay, so am I audible? Is it clear?
Yes, ma'am.
Yeah. So moment is W into L. So all of you know what moment is? What's the formula for moment? Load multiplied by perpendicular distance. So you're calculating with respect to A. So what is the perpendicular distance from the load to A? So that means AB in this case. Okay. All right. The next case, let's take a cantilever beam and a UDL throughout the length. Okay, and the length is L. And how do you define the load for a UDL? Small w, kilonewton per meter, sorry, not square. Okay, and so what are the reaction forces? So reaction forces depends on the type of support. Okay, so here it is a fixed support. So you'll have a horizontal and a vertical. There are no horizontal forces, so I'm ignoring the horizontal force. And we have MA. Okay, so case 2. So how do you calculate? RAB is equal to W into L. Okay, so W kilonewton per meter. So how many meters are there? L is the meter, so W into L. Okay, what about MA? What will be the value of MA? Load. What is a load? W into L is a load. What is the perpendicular distance? So every time you have a load UDL Consider consider this as a rectangle. And what will be the centroid? It will be in the middle. Okay, so it is L by 2. Got it? So L by 2 will be the perpendicular distance, not L. It will be L by 2. Remember that. So with that, we are done with MA. So finally, the answer will be WL square by 2 for a UDI. Okay. Now let's go to the third case. I hope you all are writing as in when I'm teaching you. So the next case is you have a cantilever beam of length L and you have a load somewhere in the middle. Okay, I'm going to name that as W kilonewton, and this is X. It's not visible. Wait, I'll draw it a little neater. Okay, this is X and this is L. Okay, does it clear? So how many points do we have? We have A, B, and C. So you have a reaction force obviously, RAV, and a moment at A, reaction moment. Okay, so what will be the value of RAV? What are the forces, downward forces that we have? W. That will be the RAV. What will be MA? It's going to be W into X. Please let me know once you are finished writing. If you have any doubts, you can ask me then and there, please. Done? All right, the third case, no, fourth case, sorry. Let's take again a cantilever beam. So you have length L, you've got a UDL only till length X. Okay, you've got the point A, B, and C. And this is W kilonewton per meter. Okay, so what are the reaction forces? RAV, MA. Okay, so what will be the value of RAV? W into X, and MA, WX is the load multiplied by, what will be the answer? What will be the distance, perpendicular distance?
X by 2.
Yeah. Why only Joel is answering? What happened to the rest? X by 2. So finally the answer is WX divided by 2. Okay, so the last case for today, and this is the most important one where people generally make mistakes. So pay attention. Okay, have a length L and a UDL on the end side. Okay, and this length is X. All right, A, B, and C. Okay, so now uh, this is given as W kilonewton per meter. All right, so you'll have RAV here and the reaction moment. So if you want to calculate RAV, what will be the value? Can someone tell me? X, so that will be RAV. What about MA? So MA is going to be the load multiplied by perpendicular distance. So what is the perpendicular distance? The midpoint of this?
L minus X by 2.
Yeah. So this distance, because we are calculating moment with respect to A. Okay. So it's going to be, how much is this distance now? L minus X. It's going to be L minus X plus X by 2. Got it? Okay. L minus X plus, this is X by 2. Got it? After this, we'll do some problems. Once you're done, let me know. Let me know once you're done. You can all switch on your videos now. We're going to start problems. Guys, are you there?
Yes, ma'am.
Abhikash, Nathaniel, Richard, why so silent? Prashant, Sam.
I'm there, ma'am.
So you're done? Finished writing?
Yes, ma'am.
Guys, I expect you to respond, especially those who switched on your videos, nod your head or something. Okay, we will do 4 problems. I want you to find out the reaction force. So if you're thorough with this, next class we will learn how to calculate the shear force and bending moment at every point. Okay. So problem number 1. So calculate what is RAV and MA. Problem 2. So tell me the answers. So RAV for the first problem is going to be 3 plus 5, 8 kilonewton. Okay. For MA, you need to consider the first. Let's go from B to A. Okay. So 5 multiplied by 4 into 2. 4 plus 2, sorry. 6. Okay. Plus 3 multiplied by 2. Are you getting it? Yeah. kilonewton meter, and that is kilonewton. I hope you guys are clear. See, when we are solving problems, I want your videos on, guys. Very few have switched on. Only 2 students. What happened to the rest? Please switch it on. Okay, Mohammed. Richin also has network issue. So please answer. Use your mic or chat box. So the next one, 5 plus, you will have 3 multiplied by 4. Yes? If you guys respond, I will know whether you are able to understand or not. I'm not able to figure out whether you're following me.
Yes, ma'am. Understood.
Understood, right? So 5 plus 17 kilonewton. What about the, so you have 5, yes, thanks, Mohammed, multiplied by 5, 4 plus 1, okay? Because we're calculating with respect to A, remember that. If you're calculating with respect to C, then it's going to be a different answer. We're calculating moment with respect to A. So 5 multiplied by 5 plus 3 multiplied by 4 by 2. There's something wrong I did. Can someone point it out? Is it 3 multiplied by 4 by 2?
3 square.
4 squared.
4 square. Good. So basically, the load is not 3. The load is 3 multiplied by 4. This is the load. 4 by 2 is the, so what's the answer?
49.
Yeah. Don't forget the units. Can we go to the next problem? All right, the next one is, this one I want you guys to solve. Okay, this is the problem that we have 10 kilonewton load on C and a UDL on the entire length AB of the cantilever beam, and the value is 3 kilonewton per meter. So please find out the reaction forces, RA and MA. Give you 5 minutes. Answer your attendance, Karan, Alan,
Present, ma'am.
Yes,
Subhash.
ma'am. I'm current present, ma'am.
Okay. Subhash,
Present, ma'am.
Richin is present. Tom,
Present, ma'am.
Anthony,
Present, ma'am.
David,
Present, ma'am.
Alvin,
Present, ma'am.
Brian,
Present, ma'am.
Astel,
Present, ma'am.
Present, ma'am.
Jacob, Evans,
Present, ma'am. Present, ma'am.
Praveen, Vishnu,
Present, ma'am.
Vishnu,
Yes, ma'am.
Jerry, Prashant, Jerry Daniel, Prashant, Mukesh,
Present,
Mukesh,
ma'am. Present,
Ashwin,
ma'am.
Rohit,
Present, ma'am.
Abhikash, Arun, Abhikash, Tarun.
Abhika said in chat, ma'am.
Okay. Tarun,
Present, ma'am. Present, ma'am.
Sam,
Present, ma'am.
Sriram,
Present, ma'am.
Arun, Sriol,
Present, ma'am.
Jason,
Present, ma'am.
Kristen,
Present, ma'am.
Akash, Eben, Mohammed, Alex,
Present, ma'am.
Sam,
Present, ma'am.
Ajay,
Present, ma'am.
Jeffrey,
Present, ma'am.
Deepak,
Present, ma'am.
Sushil, Joel, Richard,
Present, ma'am.
Gibson,
Present, ma'am.
Mithun,
Present, ma'am.
Gibson Sam,
Present, ma'am.
Barateja,
Gibson, present, ma'am.
Aditya, present. Okay, the absentees are 42, 41, 29, 28, 24, 21, and
Ma'am,
15.
29%, ma'am.
29 is present. Okay. 15, 21, 24, 28, 41, and 42 absent.
Ma'am, 42
Is
present.
anyone
Ma'am,
put
21 present, ma'am.
Ma'am,
42?
Yes, ma'am.
42 is present. Okay.
21 also present, ma'am.
21. Okay. So 15, 24, 28, and 41 absent.
Ma'am, 15%.
Okay. Three absentees, 24, 28, and 41. Okay, correct. All right, so what's the answer? I hope you're able to see my screen. Yeah. What is RA? Who will answer?
22 kilonewton.
Who was that? Okay. So how did you get 22?
3 into
Yeah.
4
Plus
plus 10.
10 into, no into. Okay. Yeah, that's correct. So you will get 22 kilonewton. Very good. What about MA?
42 kilonewton meter.
42. Are you sure? So basically we will, for 3 into 4 is the load. I'm taking only the UDL first. Okay. And multiplied by 4 by 2. Okay. Plus 10 into 2. So what is the answer for this? Shouldn't it be 44?
44.
Yes, ma'am. Yes, ma'am. It is 44.
Yeah, 44. Good. Thank you, Partha. All right. So last question for today. So in this case, what will be our AV and our MAV? I'll give you 5 minutes. Solve this. Anybody done? Are you guys trying? Okay, we've got 4 minutes left. Let me solve it for you guys. So let's go from B to A. You have a UDL. So 3 multiplied by 4 is the length plus 8 is your load. Okay, it's going to be 20 kilonewton. Okay, now MAV is equal to, calculate the moment with respect to point A. Okay, so 3 multiplied by 4 is the load. And what will be the perpendicular distance from the UDL midpoint to point A? So it's going to be 4 by 2 plus 1 plus 2. So it's 2 plus 1 plus 4 by 2. Got it? Okay, that's going to be my this thing. Plus 8 multiplied by 2. Okay, so please tell me the answer.
76 kilonewton meter.
Yes, it is 76 kilonewton meter. Okay, so we have 3 minutes. You guys have any doubts, you can please ask. With this, we have completed the basics, okay, of how to calculate the reaction forces. From next class onwards, I will start into the main subject, that is how to calculate what is shear force, what is bending moment, and how to calculate shear force and bending moment at each point on a beam. So we'll start with, so we'll be taking only 2 types of loads, point load and UDL, uniformly distributed load. Okay, and we will be considering 3 types of um, 3 types of beams. One is cantilever beam, the second one is simply supported, and the last one is overhanging. Okay, and we are also in between, we will also have 3 types of supports. Fixed support, which we have already seen now. Then we have hinge support and roller support. Okay, so for your internals are starting from 12th. Okay, 12th of this month. So till then, whatever we finish will come for the exam. So please expect um, expect small problem statements for your, like, you'll have to solve. So please keep your calculators with you while you have come for your exam. So any doubts? Okay. Thank you for